it, part 1 and 2 for assignment B, and we're going to read it. It says find the equation of the line that passes through the point 8, 3. Before we continue reading, when you are doing coordinate geometry and you're told about the equation of the line, and then there's an information talking about a point, what is the purpose of the point again? Equation of the line and then a point.
So to find the y-intercept.
To find the y-intercept. Please take note of that. I hope everybody have their notebooks, their pen, their pencil. Even though this is recording and it's replayed, but it's always good to take your notes, all right, so that you can assimilate as much information as possible. So we're going to encounter a new word there now, which is perpendicular. We talked about parallel. Anytime you hear the word parallel in coordinate geometry, what comes in mind? Anybody when you hear the word parallel? Based on what we did previously.
So they have the same gradients?
They have the same gradient. Parallel lines have the same gradient. So now we're talking about perpendicular lines. Okay? So it's like the same concept, but the only difference there now is the word perpendicular. Perpendicular lines, they cross each other at 90 degrees. So here you have a diagram taken from the notes from the booklet 2.7. Okay? Perpendicular lines cross each other at 90 degrees. Here you have the box to 90 degrees. And perpendicular line, I'm going to ask a question, even though it might sound trivial, but please, just for participation purposes, does perpendicular lines have the same gradient? Anybody? Does perpendicular lines have the same gradient? Okay.
No, sir.
Right. Perpendicular lines do not have the same gradient. Okay. One is going, for want of a better word, a different way of phrasing it, let's call it inverse. One is going inverse negative with respect to the other. So for example, here you have one line going in this direction. The other line is going inverse in the opposite direction. So the negative sign is like opposite and inverse is like 1 over, and they cross each other at 90 degrees. Do parallel lines cross each other? Anybody?
No, sir.
But perpendicular lines do cross each other, and they cross each other at 90 degrees. One is going in one direction and the other is going inverse negative or negative inverse with respect to the other. Okay, so it's a slightly different and more complicated situation. Let's go back to the question. Find the equation of the line that passes through the point 8, -3 and is perpendicular to the line y is equal to 4x plus 2. Give your answer in the form ax plus by plus c is equal to 0, where a, b, and c are integers. Now, just to recap, when we're talking about the equation of a line, to find the equation of a line, what two numbers we have to find again to complete the equation of a line? What are the names of the two numbers we have to find the equation of a line? What two numbers we have to calculate? Anybody?
The gradient and y-intercept.
Here it is, the gradient and the y-intercept. Look, I just saying it there. To find the equation of a line, all you need to find is the gradient and the y-intercept. I asked that question already, but I'm just going to repeat it. The same person can answer or somebody else can answer. We need to find the gradient and the y-intercept when we need to find the equation of a line. What is the purpose of the point? They will always give us a point.
To find the y-intercept.
To find the y-intercept. Now they must give us information to find the gradient, isn't that so? So this is why we have that equation, and this is why we have the word perpendicular. Okay, so that extra information, perpendicular, and we are given an equation, is to find the gradient. And then we're just going to represent our answer like that. That's just like an add-on. Okay, so let's bear that in mind. This point is to find the y-intercept, and this information, the perpendicular, the word perpendicular, and this equation is to find the gradient. Now, when we normally find the gradient, the equation of a line, which number we normally find first, the gradient or the y-intercept, based on what we have discussed so far?
The gradient.
The gradient.
Normally find the gradient first, and then we find the y-intercept. So even though they give us the point first, that doesn't mean we have to find the y-intercept first. We cannot find the y-intercept yet until we haven't found the gradient. Okay, because we need that equation there to find the y-intercept. And to use that equation, you need three numbers. You need y, you need m, and you need x. Y and x, we get it from the point. M, we have to calculate it. And then we can find c. So I repeat, you have to find m first, so that you can use that equation to find c after. Alright? So how are we going to find m? Perpendicular. So here you have some notes. Here's the relationship between perpendicular lines. Is not m1 is equal to m2. I normally say m1 has a negative inverse relationship with the perpendicular. Negative inverse. The whole point is that when you multiply them, you're supposed to get -1. Okay? So all this is notes or arrows. There's an example. So you can take a look at it. And then now we're moving on to our own example. Okay, because demonstration, I always believe in demonstration. Okay, so therefore now, just a minute. Example similar to question 8.1. Find the equation of the line that passes through the point 8, -11. That's for to find C, and it's perpendicular. All right, perpendicular to the line 12x plus 3y minus 5 is equal to 0. Write your answer in the form ax plus by plus c. Plus c equals 0, where a and b and c are integers. Solution to find m1. Okay, m1 now is the first gradient. M1 is the first gradient. Okay, we have to find m1. We must find the gradient first. But we need the gradient of that line already to find the gradient of what we need. We need an m2, but we have to find m1 first so we can know how to find m2 using the word perpendicular. As is, can we identify the gradient of m1? Keep that thought, keep that thought. Let's go back to the assignment question.
42.
Keep that thought. As is, can we identify the gradient here?
Yes, right. Yes.
The gradient, not the entire equation, the gradient.
4.
Yes, sir.
4.
4.
Now, why is it possible to identify the gradient here?
Because they give us the equation.
They give us an equation, but what about the
Y
equation they give us?
is already the subject.
Y is already the subject. Once y is already the subject, you can pluck out the gradient and the y-intercept.
Yes.
Okay, so in that assignment question, you can just pluck out your m1 first, right away, and then find your m2, the gradient that you want. However, in the example that I constructed, I just increased the level of difficulty just a little bit. Can we identify our gradient right away?
No, sir.
Wait, no, how is it gonna?
No, sir.
Right, because y is not the subject, so we cannot find m1 yet.
No.
So what must we do to find m1?
Make Y the subject there.
We have to make y the subject. So in the assignment question, what we are doing there now, you don't have to do it. You can get m1 right away. All right,
Uh,
you can get M1 right away, but in recommend gradient, yeah, transport is passing. Well, here it is, Shana Raphael. It seems you're close by
right.
the highway. Right. So
What you
therefore
got in
now,
now?